Hello and welcome to this FMSP online revision session. This session today is looking at the MEI 2 specification and the topic is decision analysis. So let's start by looking at what it says on the specification first of all. You have to be able to construct and interpret decision trees. Now it's really important to remember that decision trees have these three different kinds of nodes. They have rectangular decision nodes, circular chance nodes and triangular end nodes, and getting those in the right places can be important for gaining full marks in a question. You're expected to know what expected monetary value means, EMV, and to be able to compare alternatives. So when you draw a decision tree, you use the probabilities given to calculate the EMV of various outcomes. And then you have to have an idea of what utility is and use this as well. So whereas EMV simply calculates monetary value, utility is a function of wealth and takes into account other things than the simple cost of things. And it is used to calculate expectation in a similar way. So let's start by having a look at a question. We're only going to look at one question in this session because it's quite a long question, and as you can see it's an awful lot of words. So as is often the case with these decision maths questions, it can be quite intimidating, and it's important to break it down and just look at it piece by piece. So here's the first part. Still quite a lot of information here, and remember that the information is all necessary. There's no redundant information here, so we're going to be using it all. Adrian's thinking about selling his house and renting a flat. He still owes £150,000 mortgage on his house, for which he pays £4,800 a year in interest. If he sells the house, he's going to be able to pay off his mortgage and invest the remainder at 2.5% per annum, that's every year, which is the interest that he can then use to help pay his rent. Now the estate agent's given him quite a bit of information here about what he can expect to get, and he knows that a flat's going to cost him £7,500 in rent. So first of all, we're asked to draw a decision tree to help him decide whether or not to sell his house. Now we've got a lot of information here. We're going to have to do some calculations. So what I've done is I've set up a table down here to help me with the calculations. This isn't compulsory, but it's one way of doing it. And we're going to look at what sort of calculations we need to do. So first of all, the estate agent has told him that he may sell his house for £225,000, or he may get as much as £250,000, and on a really good day he might get £275,000. So let's have a look at what that means to him. If he has to pay back £150,000 on his mortgage, 225,000 will give him a profit of £75,000, and when he invests that at an interest rate of 2.5% per annum, he'll get £1,875 in interest. So if he puts that towards his rent, which was £7,500, you'll get how much it will actually cost him here, and in this case that would turn out to be £5,625 each year. If he was lucky enough to sell his house for £250,000, that would be a £100,000 profit after he paid off his mortgage, which would give an interest of £2,500, leaving him with £5,000 to find towards his rent. And best situation of all is if he got £275,000, then he'd be left with £125,000 after he'd paid back his mortgage, which would give him an interest of £3,125 and leave him with £4,375 to find towards his rent. So there's some numbers that we're going to be able to put in our decision tree. Let's have a go at the decision tree. So all decision trees start at the left hand side of the page, and the last thing you're going to do is you're going to make a decision. So there's that decision node. And we're deciding between two things. Here we're deciding whether he should stay in his current house. And if he stays in his current house, that's it. Nothing else to do. And the cost to him is £4,800 per year. That's the interest that he pays on his mortgage. Now you'll notice that I've left that as a positive number because we're doing costs all the way through. You might have decided to put it as negative 4,800 because it's something he's paying out, and that's absolutely fine as long as you're consistent all the way through. Now the other alternative is that he sells his house, and if he sells his house, we've got these three possibilities from the estate agent. So look back quickly at what the estate agent says. There could be a 30% chance that his house will sell for 225, a 50% chance it will sell for 250,000, and a 20% chance it will sell for 275,000. So there's a chance it will sell for 225,000, and the probability of that happening was 30%. We've calculated that if he sells it for £225,000, it will cost him £5,625 a year towards his rent after the interest on his profit. The second option is that he sells it for £250,000. And the probability of that happening, according to the estate agent, is 0.5. And that will leave us with £5,000 profit. Oh, sorry, that will leave him with £5,000 to pay. And finally, £275,000. Not so likely, only 20% chance of this happening. And if that happens, he will have to find 4,375. So now we've got all of the information on a decision tree. That's done. Next thing to do is to calculate what's going to happen at this chance node. Though the chance node is there because it's followed by three actions, all of which have probabilities associated with them. And to calculate the number we will put in there, we multiply the end result, the outcome at the end, by the probability of that happening. So what we're going to have in there is 5,625 multiplied by 0.3 plus 5,000 multiplied by 0.5 plus 4,375 multiplied by 0.2. And when you work all that out, it comes to £5,062.50. So now we've got an outcome here and an outcome here, and we compare the two. And because this is the amount he's paying out, these are costs to him, he wants the smaller number, so the smaller number is 4,800. So the 4,800 goes in that decision node. The decision is to stay in his house. So on the basis of that, we can write down that he should stay in his house. And that's our answer. And you should put that in a sentence somewhere on your page. I've put it up there because that's where I can fit it. Now, the second part of the question said, would the analysis point to a different course of action if Adrian were to use square root utility function instead of EMVs? So what we're going to do now is we're going to calculate on the basis of the utility, and what we're saying is that utility is the square root of, and in this particular case it's all cost, so utility is going to be the square root of cost. So if he stays in his house, then the utility is going to be the square root of the £4,800 that it's currently costing him, which is 69.28. And if he sells, then the utility is calculated by taking those probabilities that we had and multiplying them by the square root of the cost for each decision. So it's going to be 0.3 multiplied by root 5625 plus 0.5 multiplied by the square root of 5,000 plus 0.2 multiplied by the square root of 4,375. And when you work that lot out, you get 71.08. So the cost is still higher if he sells. So the question was, would it point to a different course of action? No, he should still keep his house. So that's dealt with the basic problem and also with utility, and the square root utility function, basically just the square root of the cost or the profit from what you're doing, and most utility functions that you get are either square root or else they're going to be to a power that you are given. So it's not going to be something that you have to invent as you go along. And down here the important thing is that we found the utility by multiplying our utility function by the probability for each option. Then the question moves on. Oh, hang on, let's have a look at the Marx scheme first, sorry. So first of all, this is how the Marx scheme is split up. The marks are B's, M's and A's. So the B's are independent marks, you get those anyway. And the A marks depend on you getting the M mark that goes with them. So first of all, if you've got a decision node at the beginning, you will get 1 mark. You then have to have a chance node, a round one. If it's not a round one, you won't get the mark. And a 3-way split is the other mark there. Then there's 2 marks for getting these costs, 1 for getting a correct value and another one if they're all correct, and finally 1 mark at the end for writing down the decision that he makes, so when I wrote the answer. The utility, there's 1 mark for calculating the utility function for the different probabilities, and 1 mark for calculating root 4,800 and saying that he shouldn't change his decision. Right, the next part of the question. His circumstances change, so he's now going to decide whether or not to sell in a year's time. And what's happening now is that as well as deciding whether or not to sell, he's also got all of this information about what the economic situation might be like in a year's time. So if it's less favourable, then he might sell for 200,000 or up to 250,000. If it's exactly the same, it will be the same. And if it's more favourable, then he might sell for as little as 250 but up to 350. So now we've got a more complicated problem with other things to take into account. So draw a decision tree. Assume that he still owes £150,000 in a year's time, and that the cost of renting and the interest rate hasn't changed. So we are still going to have 7,500 in rents, and we're still going to have an interest rate of 2.5%. Again, I think it's helpful to set up a table or something, because you're going to have to do all these calculations. So we have three scenarios: less profitable, the same, and more profitable. If he sells for 200,000, then that's a profit of £5,000. The interest on that will be 1,250. So when we take away his rent repayments, that leaves us with 6,250 as a cost to him. For 225, it's 1875 and 5625. Some of these calculations you'll have already done, so don't forget to use things that you've done in previous parts of the question. There's our 225 again, so that's still going to be 1875, 5625. And this one is still going to be 2,500 and 5,000. And here, if we manage to sell for 275,000, then we'll have interest of 3,125 and 4,375. So it looks quite frightening, but in actual fact there's not that much calculation to do really. And last of all, if he manages to make £200,000 profit, he's going to get £5,000 in interest, leaving him with only 2,500 to pay towards his rents. So then we have to draw another probability tree. And here I started earlier, because they're a bit of a pain. So this time, decision node, stay, 4,800. That doesn't change. If he decides to sell, then there are three options. Economic conditions could be less favourable, and if they are less favourable, then we've got three possibilities there, which we worked out before as being 200,000, 225, 250. So I'm just going to put 200, 225 and 250 and not bother with the thousands at the moment. And the probabilities are 0.2, 0.3 and 0.5. So those are the probabilities the estate agents gave. The numbers on the end came from the table that we calculated a few minutes ago. Now, if the economic conditions stay the same, then we're in a situation where we've got the possibility of selling for 225 with a probability of 0.3, 250,000 with a probability of 0.5, and finally 275,000 with our probability of 0.2. And we've already calculated these outcomes. And last of all, if things improve, then it's 250, 300 and 350. with probabilities 0.3, 0.5 and 0.2 respectively. And outcomes as we calculated before. Whoops, I just nearly reduced his payments by 10%. There we go. So that's all the information on the tree. Now it doesn't look very beautiful, and they never do, but as long as they're legible, that's fine. I think one of the important things is you'll notice I started with my decision box up here because I knew that one of my options was going to be stay that had nothing on it, and that I needed all my working space down here. So working these out, I'll just do the top one. I'll write out the top one as the example. That's going to be 6250 multiplied by 0.2 plus 5625 multiplied by 0.3 and 5000 multiplied by 0.5. And when you work all that out, it comes to £5,437.50. Whoa, sorry, it won't quite fit in my box. Do the same for the others, and this one is 5062.5, and the one down here is 3875. So that's one set of chance nodes done. And then we have to work back to the second chance node, where we take the results from the level we've just worked out and multiply those by the probabilities and add them all up. And when we do all of that, then what we end up with in this little box here is 4,700. So bearing in mind again that these are costs and he wants the lower one, in fact now it becomes 4,700, and in this case he should sell his house. So there we are. That's the answer to that one. Looking at the Marx scheme, you can see that this is all beautifully set out, but exactly the same numbers here. You get the M1 for the new chance node here, and A1 for getting the three-way split, but you don't get that if that isn't a chance node. You get 2 marks for the less, 2 marks for the more. Of course you don't get anything for the same because it's exactly the same as we had in the first part. And you get a mark for reaching a conclusion, but you must write the answer as well. You wouldn't have got that mark just for finishing the drawing off like this. And that completes the question. The examiner's comments, well, the question was answered very well. Computations and paybacks in parts 1 and 3 cause difficulty. So where I set out my working in a table, that was where the majority of people had difficulties with their calculations, and that's why I think it is very useful to write down what you've done and to put it in something like a table, because it helps you to draw your diagram and it also helps the examiner to see what you've done. But generally well done, and even the utility bit was handled very well, which is good. So this is a good question, provided that you've learnt your stuff. Okay, that's the end of this session on decision analysis. It only remains for me to say good luck with your examinations, and I hope everything goes well for you.